Hi guys, so today we're going to take a look at question 4 from paper 2 of the 2015 exam. Alright, so we have two circles, S and C, which touch internally at B, as shown. Okay, they touch internally at B. And the equation of the circle S is x minus 1 squared plus y plus 6 squared equals 360. Alright, so S is the bigger circle. Alright, so we want to write down the coordinates of the center. Alright, coordinates of the center. And then we want to write down the radius of S. Write down the radius of S. And in the form a root 10. So straight away, let's write down our equation for S. S x minus 1 squared plus y plus 6 squared equals 360. Okay, so we have two equations for the two formulas for the equation of a circle. The first formula, formula 1 is of the form x minus h squared plus y minus k squared equals r squared, where h is where center hk and radius r. Alright, and then our second formula, formula 2, this is just from the log tables, is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Alright, so which does the formula they've given look like? Well, it looks like formula 1. Alright, so let's just match things up. So minus h must be minus 1. So in the place of h we have 1. So h equals 1. And k equals minus 6. And then r squared must be 360. R squared equals 360, which means r equals the square root of 360, which is just 6 root 10. Alright, so this has center hk and radius r, and we found h and k, so it must have center 1 minus 6 and radius r, which is 6 root 10. Okay, so this is our answer, or answers. Alright, now on to part B. The point K is the center of circle C. Alright, we can see that. The radius of C is 1/3 the radius of S. Okay. The coordinates of B are 7, 12. Okay, coordinates of B are 7, 12. Alright, so first of all, let's write down what the question is telling us. So the radius of C, let's call that RC, is equal to 1/3 the radius of S. So we can actually now calculate RC because we've just calculated the radius of S in the previous question. So this is just 1/3 by 6 root 10. And this just equals 2 root 10. Now, we may need this, we may not, but it always helps to get this information down. And we also know that B is 712. Okay, so let's take a look at this diagram. We're going to call the center of S A, and let's connect A and B. Okay, so we know that K is on the line here, and we know that, let's have this line K to B, and this line A to K. Well, we know that A to B is the radius of S, so let's write that down. Actually, AB is the radius of S equals RS, and KB is the radius of C. Is the radius of C. And so this is AB, and since RC is 1/3 RS, this is just 3RC. And so AK is AB minus KB. So this length here is AB, the whole length, minus KB. All right, so AK equals AB minus KB. And this is just 3RC minus RC, which is just 2RC. Okay, so in other words, AK, so K lies 2/3 of the way from A to B. So if you were traveling from A to B, if it was a journey, then K would lie 2/3 of the way on that journey. All right, well, let's look at A to B. Let's look at AB. Well, it goes from A, which is 1 minus 6, 1 minus 6, to B, which is 7, 12. Okay, so in the x direction, along the x-axis, it travels 7 minus 1, 6 units. So it travels 6 units in the x direction, and it travels 12 minus 6, 18 units in the y direction. And it's constantly moving in that it's moving in a straight line. So 2/3 of the way along this path would be 2/3 the x direction and 2/3 the y direction. So it would be 2/3 by 6 in the x direction equals 4 units in the x direction. And 2/3 by 18, which is 12 units in the y direction. All right, so let's start at A. So now if we start from A and we travel 4 units in the x direction, where will we go to? A will end up at 1 plus 4. Will end up at 5 minus 6. And then if we travel 12 units in the y direction, so 12 units in the y direction minus 6 plus 12 is 6. So it'll be 5, 6. And then that's 2/3 of the journey from A to B. So we're at K. So this equals K. Now, part 2 of B, find the equation of C. Alright, well, what is the equation of a circle? Well, we actually did it earlier, but let's just put it in again. X minus h squared plus y minus k squared plus equals r squared, sorry. Equals r squared. Just using the log tables. Now, we could also write it as x squared plus y squared plus 2gx plus 2fy plus c equals 0. And it's not obvious which is the better way to do it. Well, what do we know about C? Well, we know its center, so we know C has center 5, 6. And, well, we actually know its radius. C has radius 2 root 10. So, in this case, it's definitely easier to use the first formula because we have h, we have k, that's just the center hk, and we have the center, and r is just the radius r. So it definitely is easier to use this formula. So let's just plug it in. X minus h, which is 5 squared, plus y minus k, which is 6 squared, equals r squared, which is 2 root 10 squared, which is 2 squared by root 10 squared, which is 4 by 10. 40. Now on to part C. Find the equation of the common tangent at B. Alright, so that would be this line. Let's say this line here. Let's see if I can draw it. Hey, not so bad. So something like this. Alright, so give your answer in the form ax plus by plus c equals 0. A, B, C are integers. Alright, so, well, firstly, what is a tangent? A tangent is a line that touches a circle at exactly one point. Exactly one point. Another important property of tangents is that the tangent is perpendicular to the radius. Perpendicular to the radius. Now, when I say that, I mean like the radius line from the center to where the tangent hits the circle. So in this case, the tangent, let's call the tangent T, is perpendicular to AB. Okay. And what do we know about perpendicular? Well, perpendicular means the product of their slopes their slopes is -1. All right, so I think it's so important knowing your definitions and getting them on the page makes the question so much easier. All right, so we want to find the equation of the common tangent. Well, so the equation of a line. Well, how do we get the equation of a line? Well, to get the equation of a line, we need a point. So let's say equation of a line. We need a point and the slope. All right, well we have a point. We have a point, B. B has to be on the tangent because it's where it hits the circle. So point is 7, 12 equals B. All right, so how will we find the slope? Well, we know that the product of this slope, so let's say the slope is M, we know that M times the slope of AB equals -1. Well, what is the slope of AB? There's a lot of things to do here, but none of it is that difficult. All right, so let's try and find the slope of AB. So we can find M. Slope of AB equals the rise over the run. And the rise is 18. Remember, we did that 18 units in the y direction and 6 units in the x direction. So it's 18 over 6 equals 3. So M by 3 equals -1. So M equals -1 over 3. All right, so we have a point on the line and we have the slope. And so now we can use the equation of a line formula from the log tables. Equation of a line which is y minus y1, that's the point we need, equals m by, which the slope we need, x minus x1. Alright, so x1 is 7, y1 is 12, and m is -1/3. So we have everything we need. Y minus 12 equals -1/3 by x minus 7. Okay, so let's just multiply out, bring the -12 across. Y equals -1/3 x plus 7 over 3 plus 12. So the equation of the line is y equals -1/3 third x plus 43 over 3. Okay, so we have the equation of the line, but it's asking us to answer in the form ax plus by plus c. All right, so let's bring the x and the constant over. So we get 1/3 x plus y equals minus 43 over 3 equals 0. And careful, it wants a, b, and c as integers. All right, so let's multiply across by 3. So x equals x plus 3y minus 43 equals 0. And that is the equation that we are looking for in the form that we wanted. Right, this is actually a fantastic question. that really outlines kind of the method that I think it's good to follow. So the typical way that you would look at this question is you read the question, how do I get the answer? How do I get this equation in the form I want it? And kind of the way that I think it's better to approach these questions is to think, well, what are you giving me? What do I want? How do I get it? So what are you giving me? Well, you're giving me the tangent. We're looking for a tangent. Well, what is a tangent? Okay. Now, what do I want? Well, I want the equation of the line. All right, well, how would I get the equation of the line? And that first bit of seeing what we have usually helps a ton in getting what we need, because they don't really give you information that you don't need. They don't really give you that information very often, almost never. So outline what they're giving you, outline what you need, and then figure out how to get it. Just break it down, make it simple,